Good morning or afternoon, everyone. Welcome. Thank you so much for joining us today for a Marine Technology Society member webinar. I'm Abbey Wakely, your moderator for this session. I'm so excited to showcase the impactful initiatives from our MTS member, Seabird Scientific. Before we dive in, I want to kick things off with a brief overview of GoToWebinar. As a reminder, this session is being recorded. If you have any technical questions for me or questions for the presenters, kindly type them in the chat box using the tablet icon. I'll promptly address your questions or relay them to the presenters at the end of their presentations. All right, let us get to why you are here, the webinar. Today we have a team from Seabird Scientific to discuss their new product, Fathom. Dane Lucas has been a software engineer with Seabird Scientific for 3 years and works on developing new software for customers. When he's not working, he spends his time running, playing video games, and entertaining his 2 cats, which you might see one today. Ryan Anderson's journey into software started with data processing. For most of his career, he worked on deploying oceanographic instruments in both estuarine and open ocean settings. He has been a software engineer with Seabird Scientific for 1.5 years, predominantly focused on new software development. Most weekends, you can find him backpacking or skiing in the mountains or on the water sailing. Heather Eberhart has been a product manager for Seabird Scientific for 7 years, focused on software and systems. Her background is a mix of human-centered design and engineering and oceanography. In her downtime, you can usually find her out in nature with coffee and a good book. All right, welcome all. Let's go ahead and start the webinar. Heather, I'm going to let you take it away.
Awesome, thank you so much. Perfect. Well, first off, I just want to say hey to everyone. Thank you so much for joining today. So like Abby said, my name is Heather Eberhart. I'm one of the product managers here at Seabird Scientific, and we're thrilled to dive into our new software, SBS Fathom. For many of you, this might be the first time you're seeing a new software release from Seabird Scientific. You may actually be wondering why we're even releasing new software. And quite simply, it's because the people working with our instruments asked us to. While the current software offerings have a great deal of functionality, they're not necessarily intuitive. In fact, some pieces of software could be described as ambiguous or clunky. And we knew that there was so much room for improvement. So let's take documentation as an example. People would dig into instrument manuals, software manuals, Seabird University trainings, app notes, and more to understand how to use the software and what's going on behind the scenes. And it shouldn't take days of reading to feel confident when setting up and deploying your instrument or when processing your data. With that in mind, we've now included a deployment menu in our software to guide you through a deployment with tooltips that can offer additional information about key settings. For data processing, you now have access to our GitHub repository, which you can use as a reference or can clone and use to build your own processing tools. There are 3 main components to this data processing documentation. One is a plain text description of each of the data processing modules. The second are the formulas used in their proper formatting, and the third is working Python code. But I'm getting ahead of myself in my excitement. Ultimately, SBS Fathom is intended to replace all software that supports instruments that are currently offered. But we had to start somewhere, so this initial release supports the SBE 37, all flavors, and SBE 19 plus V2. We focused on the current firmware versions for each instrument for this initial release. And Fathom is available on Windows 10 and newer and Mac OS 13 and newer, which means that for the first time ever, you're able to work with SBE 37s and 19 plus V2s on Mac. You're also able to connect multiple instruments simultaneously, which was not an option previously. For those who are familiar with these instruments and the CSoft software suite, our demo will cover how Fathom rolls these disparate pieces of software into one interface. For example, our terminal and deployment sections cover CTerm v2 functionality, the real-time section covers CSAVE v7, and data covers SBE data processing. Other tools like the deployment endurance calculator are also included. But how did we know that we were on the right track with the design choices we've made so far? We actually did extensive design validation and beta testing with you, researchers, technicians, and many other subject matter experts. Our beta release included over 125 participants who were given the opportunity to provide feedback to guide our development priorities. But what if you didn't work with the 37 or 19 plus V2? Well, we're going to be rolling in additional instruments regularly with new releases each quarter. We don't have specific dates for the addition of each subsequent instrument at this time, but if there's any that you'd like to see included earlier, please let us know. Note that while we intend to have larger releases quarterly, we'll still be able to release much more quickly if any critical bugs arise. And we also have the ability to incorporate feature requests from all of you. So if there's something you'd like to see included, please reach out to our tech support team. With all that covered, let's actually go ahead and just deep dive into Fathom. So Ryan can go ahead and take it away.
Just 1 second here, I'm going to get my screen shared. Okay, yeah, I'm Ryan Anderson. I'm one of the software engineers at Seabird Scientific, and I've been working a lot on this project, so happy to demo a bunch of new features that we have here. So basically, there's 3 different parts to this application. There's this 3 different panels. So on the left here, we have all our diagnostic information. So once you're connected to an instrument, you can see the firmware version, calibration coefficients, and deployment duration. So that would be how long the instrument's going to last out in the environment based on the current settings. In the middle panel, we have all the connection settings. So this would be for connecting to your instrument through a serial port, or disconnecting or switching to a different instrument. And on the right, we have all the panels for sending settings to an instrument, collecting data in real time, doing all the data processing. So let's get started with actually connecting to one of our instruments. The software right now is currently sifting through all the ports that are available on my computer and figuring out which ones are available for us to connect to. I know my 19 Plus right now here is connected on COM42, so I'm going to start with that. I don't know what baud rate it's at though, so I'm going to just try all the different baud rates. I'm just going to try to work through and figure out which ones that are actually the instrument is connected on. The software is now going around in the background, trying those different baud rates, trying to connect to the instrument. And just in a few moments here, it's going to pop up which instrument is currently connected on COM42, and then we're going to get a lot of status information based on that. Just takes a second here. Okay, so it found the 19 Plus, which is great. And now we're connected. Here on the bottom, we can now see we have some status information. We figured out what instrument we're connected to, serial number, what mode it's currently deployed in, and what the baud rate was. And all of these panels are now populated too. So now we have the firmware that's on this instrument, calibration coefficients, including what dates they were calibrated at, and then the deployment duration, which includes a lot of information on the battery, how much memory is available, and all kinds of different information based on the current settings that are on the instrument. You'll notice that we have these little icons here. These are tooltips. And if you click on them, they'll give you a little hint on what that information is. You'll see these scattered throughout the application, and they're really designed to basically take the place of what a manual is. It's kind of just inline help for helping you figure out what a different setting means. Okay, so now we're all connected. Let's actually go through deployment. We're going to set this instrument up for some real-time data collection. That would be the equivalent of what you would do in C-Save in the past. And so let's say this instrument was about to be deployed off of a ship going down through a profile. We're going to add all those settings and configure the instrument so it's can successfully do that. So I'm going to start over with a new deployment. I'm going to click this Make New Deployment button. I'm going to clear all the old settings that I have. And the first panel we have here is our metadata. So this is information that's not required. It's not going to be sent to the instrument, but it's going to be used in the report file. So it's definitely useful for your own tracking. I'm going to put in my own name. Maybe we'll put in some stuff for demo. And then these 2 boxes are for calculations of the memory and battery endurance. So these are, again, optional, but useful to put in here. There's no auxiliary sensors on this instrument, so I'm going to say there's no power draw from the auxiliary sensors. On this panel, panel 2, is all the settings that apply to this specific instrument. These settings, what shows up here is dynamic. So if you're connected to a 37, you're only going to see settings that are applied to that instrument. It also does a lot of checking to make sure that you're putting in settings that are valid. So if I put in, say, scans to average is 0, that's not valid. And so it has to be an integer between 1 and 240. start with 5 because that will be a nice round number. Since we're deploying this in real time, I'm going to check this button, and it's going to shortcut some of these settings and automatically set them for what we need to do for real-time data collection. So you can see the output format was fixed to raw hex data, and we're going to ignore the 19 plus as a switch on this side of it. I'm going to put in 0 for minimum conductivity frequency. That just controls the pump and the pump delay. Down here on the bottom, now that I've filled in all this information, we now have some calculations based on those settings. What I put up here in these top boxes, how long it's going to take for the instrument to fill up the memory. So that's 86 days. And then it's battery based on brand new batteries going into the instrument. Currently, it would last 2 days and about 14 hours. This instrument is actually powered by a power supply, so we can kind of ignore that. So not important. This panel is going to generate 2 files for us. One is a configuration file. This is a new file type, new to Fathom. Basically, this is a configuration file that's going to be generated, and you can use to, it has all the settings that we just put in, and you can use it to deploy another instrument. So let's say I had a bunch of 19 pluses that I wanted to be deployed the same way. You can use that configuration file to make sure that all the settings get onto each instrument identically. The report file also has all those settings that were successfully sent to the instrument, and then a readout of all the settings and all the configurations that are currently the configuration of the instrument. This is our last panel. So this is about to send all the commands to the instrument. At this stage, it's a good idea to go through and check to make sure that you really got all your settings right, that you actually want to put it into profile mode. You actually want to do 5 scans per outage. These all look good to me, so I'm going to click the confirm button, and it's going to start to send all those commands to the instrument. It's currently communicating through the serial port, and then it went through and verified that all of those settings were actually set. We got a little message at the bottom saying the deployment was successful, but since we clicked that real-time button, it wasn't actually started. So it's not actually recording data yet because it didn't send a start command, or we didn't set a start date in the future. And that's what we want. That's the deployment. We've successfully done that. I'm going to exit out of this panel. And now we can go over to the real-time panel. Here, we can set up all the settings that we have to do for real-time data collection. I'm going to load in a XML con file. This contains, if you're not familiar, all the coefficients for the sensors that are on the instrument, specifically for the auxiliary sensors. So you have a bunch of auxiliary sensors, all the coefficients need to come from that XML con file. In this case, we don't have any auxiliary sensors, so they didn't pop up, but you can see we have different drop downs for each parameter. So we can select the units that we want the temperature to be in, the pressure, and the conductivity. If you had an eco sensor or a dissolved oxygen sensor, there would also be drop-down options there to select what units you wanted those parameters to be in. Salinity and depth are also 2 derived parameters that we can add. I'm not going to add them now. And you need latitude and longitude to calculate those. Okay, now we're ready to start collecting some data. I'm going to click this start button, and that's going to send a start command to the instrument. And that's going to start recording data both on the instrument itself, so it's being added to the memory on the instrument, but it's also being transferred to the computer and being stored on a database that's within Fathom. You can see data that's coming in live here. Obviously, it looks like garbage because this is an instrument that's just on our desk, so it's a bit of a random noise. But you can see that there's a lot of data coming in real time. This plot is probably one of our more exciting features. It's very interactive, so you can zoom in on data. You can also grab one of the axes and scroll it around relative to the other one. And you can also shrink it down so that you change the scale of the data by grabbing the furthest right point. And then you can also turn on and off different series by double clicking on the legend. So let's say you didn't want to see temperature. You just want to see conductivity. You can turn on and off there. Okay. Next, on to metadata that you can associate with this data that's coming in real time. Let's say you've had an observation and you wanted to note that. You could click this Mark Scan button, and that's going to grab what scan you are currently on. So we were on Cas9, scan 62, and that scan is now marked. And let's say we saw a fish there. But maybe you hit the button wrong, and you actually want it to be on Cas 58, on scan 58. You can scroll down to that, go to 58, you can mark it, and you can add in your note of what you observed at that time. So you can go back and forth and adjust the metadata while data is coming in the real time. I'm gonna go back up to our one we marked. That was the one that we made incorrectly, so I'm now correcting that metadata, and we can clear that out. Similarly, you can add metadata for the whole cast. So you can say, okay, Cas9 was for station B, and that will be captured into the database. Down here, we have all kinds of controls for the plot, so it's very customizable. You can switch which parameters you want on which axis. You can do subplots, so you can have two plots next to each other. And you can also adjust things like the font size, the marker size, or the colors of different series. So we'll change one of these. We can change the conductivity to an amber. Looks like we ran into an issue there. Oh, there it comes. Now I'm gonna hit the stop button here. And so we're done collecting data, and we can move to the next panel. This is our final panel for real-time data collection, and this is for exporting data. I'm going to export it out to my downloads folder, and we can generate a hex file or a CSV file, and then we can also generate some other files that are relative to our metadata. So the mark scans can go into a separate file, and then we can also subset which cast that we want. So maybe we only want to export Cas9. We can put in a 9 here and only export that. I'll do all of them for now. Hit the confirm button, and we should get some new data out. There we go. And there's our hex files and our CSV files. You can also see we got that configuration file and the report file from our deployment. So that's all the files that we just generated. Okay, one other thing I'll show here before I hand off to Dane is the terminal. So if you're a real power user and want to go back to using commands, you can do that here. And you can scroll all the way back and see everything that's happened, even from the connection point. So you can see when we were doing the connection, the software was sending commands like getSD to get the state of the instrument and learn the current state. So that is an option here. Okay, I think that covers everything on my side. I'm now going to hand it over to Dane, and he's going to walk us through a lot of the data processing.
All right, thanks, Ryan. Yeah, as you just mentioned, I'm going to be going ahead and taking a look at data processing, but I'm also going to be going ahead and taking a look at how to actually do a data upload from your instrument as well. So I'm connected to a different 19 plus V2 here than the one Ryan was just connected to. And I'm going to go ahead and I'm in the data tab right now. I'm going to go ahead and save some instrument data to my computer. So as we just saw Ryan do, you can get your data out of your instrument from going ahead and running it in real time, and you can save out a hex file that way. But what if you're using a moored deployment, or you're connected to a 37 SM and you aren't running it in real time? Well, that's what a data upload's for. That's how you can get your data out of there. So I've gone ahead and I can go ahead and choose whatever settings I want for my data upload. I'm going to keep mostly with the default ones, which will upload all of the data that's on here. And I can also choose to add some header information if I wanted. So I can go ahead and put demo in there, and I can have a value for it. There's some sort of free-form notes that you can stick in there if you want to have any sort of information about any information about this data, where it's coming from, or anything like that. Wherever you're saving files out via the application, you saw this a lot during Ryan's presentation as well. There's always an opportunity to change where the location is, but there's always a default location already selected. So if you just want to use the default, then that's also fine. You can also choose to change the file name. I'm just going to leave it as this because it has all the information I kind of want from it. I'll go ahead and hit next, and that'll actually start the data upload. There's not a lot of data on this, so it's going to go really fast, which is great. If there is a lot of data, then it might take a little while to get through all of this data upload. But that's what the progress bar is for, to let you know that it's still working in the background. But we can go ahead and hit confirm, and then we can go ahead and take a look at our directory where we saved it to, and we've got our hex file and we've got our XML file there as well, which is great. Those of you who have used a lot of Seabird scientific software before might be familiar with the hex files and the XML files, and we'll be talking about how we're actually using them for data processing, which is this other option in the data tab. So we need to load in two different files for data processing. One is we need to load in a hex file. I'm not actually going to load in the hex file that I just saved out because it came from an instrument that was just sort of sitting on a bench, so it's not going to be particularly interesting data. We're going to load in some data from a different 19 plus profile that is actually more interesting, that we can actually look around with and play with a bit more. We're also going to load in an XMLCon file associated with that instrument. Many of you might be familiar with XMLCon files. They tend to contain the calibration coefficients for our instruments. And sometimes the hex files will have calibration coefficients, but the XMLCon file is generally more of a source of truth. A lot of times Seabird will be providing those for you. And when you load them in, we actually check to make sure that the calibration coefficients are the same between your XMLCon and your hex. In this case, they weren't the same. There's some sort of disparity between the calibration coefficients. So the software is going to ask you which source of truth you actually trust a bit more. In this case, I trust my XMLCon quite a bit more, so I'm going to stick with that. The other benefit to loading in your XMLCon file is particularly for a 19 plus V2, if you have some auxiliary sensors attached like this one does, then you're going to need that XMLCon file to actually get some of those calibration coefficients for the auxiliary sensors. So in this case, I've got a SB43 oxygen sensor attached to this 19 plus V2. So I needed that XMLCon to be able to get the calibration coefficients for it to then subsequently process it correctly. But now we can see this data conversion tab, which looks quite similar to what Ryan was just showing via the real time. So I can go ahead and select whatever options I want here for temperature, pressure, and conductivity. Let's go ahead and change it to degrees Fahrenheit just for fun. We have a conductivity we can also change as well. I'll leave those just the same. And then oxygen, we can choose a number of different units that we want as well. I'll go ahead and leave that as the default. Some of you who have used our SB43s before might be familiar with tau correction, hysteresis correction for the data for the SB43. Those just apply some very minor accuracy corrections based off of some different conditions to them. I'm going to go ahead and leave those both on just for simplicity. There's also some extra settings for those, and we can choose the latitude and longitude as well, and this will be used later on in data processing if we so need it. Various different formulas sometimes require it. I'm going to leave it at 0 and 0. I'm not actually sure where this data is directly from, but it won't have too big of an impact, fortunately. Now we have this big list of checkboxes here, and those of you who have used SB data processing before might recognize some of these names. Each one of these corresponds to one of the data processing modules that you would be running via SB data processing. So previously, what you'd have to do is if you wanted to run, let's say you wanted to run filter and cell thermal mass and derive TEOS10, you would load in your file first into data conversion, then get your CNV file out. Then you take that CNV file, load it into filter, run it, get that file, then load it into cell thermal mass, run it, get that file out, and so on and so forth for every single one of these modules. And that's no fun. That's very slow, and it's very tedious to do. So instead, what if you could just select all of the modules that you wanted and then run them all at once? That's something that we've enabled via the Fathom software that we can go ahead and take a look at as we continue through here. But first, by clicking next, we're going to actually convert all of our data into those engineering units that we just selected above. And we're going to see them on the plot here. Great. So this is all of the data that was in that hex file that I just loaded in. So it's a relatively short cast all the way down to nearly 25 decibars of pressure. So that's around 25 meters, right? And we can go ahead and if we wanted to, we can zoom in, like maybe we're really interested in this section. We can zoom in on the plot and take a look at what's going on in there. But this just gives sort of an overview of what we got, and we can really set up the plot however we want. So if you might recall that we actually also converted oxygen. So we want to actually add that to the plot as well, so we can have all of the data that we're really interested in showing at once. So that's just processing real quick. And then now we can take a look, and there's our oxygen on the plot as well. Awesome. We can go ahead and if we wanted to, we could change some other aspects of the plot to really design it however we want. But the way we've got it right now, it looks good to me. So we're just going to leave it and go forward. Now we have data processing. So here we have the modules that we selected. So we selected filter, cell thermal mass, and derived Teos 10. Now I can go ahead and configure these settings however I want to really make sure that everything is looking right for my data. And the nice thing about this software, this Fathom software, is that you can go ahead and run the data processing on your data and see the changes live update on the plot. So this completely removes all of the guessing and checking you might have had to do in the past with your data, where you're not sure whether you want to put 5 or 6 for a value in one of the modules. And you kind of have to wait to the end to actually go ahead and look at it in a plot and see what the effect was. This allows you to be a lot more confident in how you're processing your data, because you can apply the entire workflow at once and quickly see the update on the graph. And every time you apply the workflow, it's always starting from fresh. So you don't have to worry about accidentally messing up your data. So for example, if I went to my into the temperature time constant and filter and say put in, I don't know, 15, and I hit apply, I'm going to expect quite a big difference to show up for temperature. But that's okay, because once that happens, then I can always start again. So my temperature data looks a little bit weird now. I don't know if that's what I want. Here's a cat. We promised that would happen. So I don't know if that's necessarily what I want. So maybe I can go ahead and change it and go back to something more reasonable, like 0.5. Then if I hit apply, none of my data is lost. It's just we're starting from scratch again, and that's okay. So now it's back to looking pretty similar to how it was before. So we have basically that ability to run that for all of the data processing modules. So as you're stepping through, you can be confident in seeing exactly what each individual change you're making, what effect that's having on your data. So you can be a lot more comfortable with it and feel a lot safer about just sort of playing around with your data and learning how these different modules are affecting your data. You can also run derived Teos 10 to derive a lot of really interesting values about your data. So for example, I might be really interested in absolute salinity for my data, for example, and how about density as well? So I can go ahead and apply. And you don't currently have the ability to add those to the chart to also visualize those, but that's something that's going to be coming in the future as well. So we can continue onwards, and now we can actually save out the data because there's not too much benefit in running data processing if you're not actually getting the output as well, right? So you can go ahead and change the file name if you want. I'm just going to call this one demo. And there's a number of different formats. This is somewhat similar to real time, where you can have CNV and CSV files. You guys might be very familiar with those. The header files and the ASCII files are both also pretty helpful. The header file just contains like the header metadata that you might find in one of our output files, and the ASCII file it's somewhat similar to the CNV and the CSV file, except it just has the data, but you also have a lot of extra options for sort of customizing what you want your data to look like. So for example, I'm going to choose that I want to include my column names. And if you want, you could add a first column in here. I'm not going to personally do that, but you can choose a column separator that you want. So I can choose, let's separate our data with colons this time. That could be fun. You can choose to, if you want to, if you had some of your data that was marked bad by one of the data processing modules, but you want that value to be showing as something else, then this is your opportunity to go ahead and replace that for the ASCII file. So there's a lot of customizability for how you want your files actually look when you get done with your processing. But if you go ahead and hit confirm, all of those files are going to go ahead and get saved out, and we can really quickly go ahead and take a look. So here we go. Here's our 4 demo files with the different extensions. Here is the .ascii file. So let's go ahead and take a look at that one, because that's the one we just talked about the most. And we can see we've got our column names at the top, and we've got all of the values that we have for all of our different variables that we saved out. So looks like the data was mostly around 77 up to 80 or so degrees Fahrenheit, which is cool because that's the values that we set. And you can always go ahead back into here and run some completely different modules on your data and see how that looks as well. So this is one of the great things about this SBS Fathom software, is that you have so much flexibility in how you're running these workflows and processing your data and becoming a lot more comfortable with it. But with that, that's most of what we have. The last few things that we want to talk about with our software is that we have a number of different tools that are useful. And some of these are tools that you don't actually have to have your instrument connected for. So for example, we have standalone battery and memory endurance calculators. Those can be useful for if you want to go ahead and identify and sort of plan a cruise, see how long you have for a specific deployment, see how long you can leave a board deployment available out there for, and see, like, you know, will the memory fill up too fast? Will the battery run out too quickly? And get that a lot more comfortable with actually planning your deployment. So those are some options that we have. We also have various options for verifying your instrument operation. Those ones actually you do have to be connected to your instrument for, of course. And then we also have a built-in XMLCon editor specifically for the 19 plus v2 right now that can allow you to make minor edits to your XMLCon files or to generate completely new ones if you have all of the information, but you just don't have the XMLCon file format set up itself. But with that, that is the bulk of what we've got here in the SBS Fathom software. So I'll go ahead and pass it back over to Heather.
All right. Awesome. Thank you so much, Dane and Ryan. So I think at this point, we have a number of questions that I know were submitted ahead of time, and then I think we'll be probably taking some questions live as well. So I think Abby, you'll be kind of leading that, and then we can kind of close out once we get through some of those questions. Can close out real briefly.
Yeah, great. Thanks so much, Heather, Dane, and Ryan. What a wonderful presentation. And as Heather said, use the tablet-looking icon to type in your questions. We have about 10 that have already come in. So Dane and Ryan, I hope you're ready. I'm going to start off with the first question. Do you have any mechanisms implemented to check for the quality of collected sensor data?
Yes, I can talk a little bit about that. Yeah, so we're kind of two parts of that. There's before you even put the instrument out for deployment, we have all those verifying instrument operation tools, and that's what we're looking at right here on the screen sharing. So we have some tools in there to make sure that the sensors are actually working properly before you actually deploy the instrument. And then the second part is really kind of how is done through data processing. There's not necessarily like a real thumbs up, thumbs down, like your data is good. We kind of leave that to you. But you know, a lot of our tools in the data processing are designed to filter out bad data and work through your data and identify bad problems.
Awesome. Thanks, Ryan. This might be another question from Joe. Does it only show the most recent calibrations, or will it show all past calibrations?
It's the calibrations that are currently on the instrument, so it's only the most recent calibration. Yeah.
Perfect. And this isn't related. It's a two-part question with sensors. Will it recognize third-party sensors, and what about peripheral or additional sensors on a 19 plus?
Mm-hmm. So currently we're supporting on the 19 plus V2, we're supporting the 63, the 43, two dissolved oxygen sensors, and then the EcoFL NTU and the EcoFL. So those 4 auxiliary sensors. We're planning on adding a lot more, including third-party sensors. And I think, Dane, you can talk a little bit about the exponential and linear equation that we're going to have to do a lot of the data processing. But basically, it's all identified through the XML con file. It's not necessarily through the instrument. So your XML con file has those sensors listed and configured there. Eventually, that's going to be fully supported.
Yeah, so to add on to that, we're working on adding in being able to have essentially parametric custom polynomial equations that you can add in. This is something that SB data processing has as well, that would allow you to basically any of your external voltage sensors that are just using a polynomial equation, we can allow those to be in there. So we don't have to specifically identify what sensor it is, but if you know what it is and you know what the equation is that you want to use for processing that data, then we can support it. So that's something that's going to be coming in an upcoming release for sure.
Awesome, we're looking forward to it. And Ryan, I think you answered this question, but what is the format of the configuration file? Is it still in XML?
Yeah, it's an XML based format. Yeah.
Perfect. And then we have another question. What is the maximum number of parameter series that can be plotted at once in the real-time acquisition?
Like the max number of casts, I'm guessing, which would be the separate series. You can basically go back and plot any of them that are in the database. So there shouldn't really be a limit on that.
Perfect. And then can you still process several files at a time?
Currently, there's just processing for one file. Adding multiple files in at a time is something that we're also working on. That'll take a little bit more work to get there, but it's definitely on the roadmap for something that we want to get done. So keep an eye out for that for sure.
Awesome, thank you. And then in regards to processing again, do you plan to still include recommended processing settings for different CTD models in the processing instructions?
Yeah, so that's a good question. So it's sort of two parts to that. Yeah, we currently already have those sort of recommendations that you might be familiar with from our SBA data processing manual. Now we currently, and Heather might be able to talk a bit more about this, or perhaps Ryan, that we do have a sort of new, different way we're doing our documentation for our data processing, and that can be a lot more verbose. It's going to be including the actual Python code that does the data processing, and we can call out a lot more suggestions there. But since we're currently just talking about the 37 models as well as the 19 plus V2, those are the only suggestions that we're going to have for now. But as we expand it, we can be a lot more verbose in those different recommendations.
Awesome.
As a bit of a side note to that, we didn't talk about this, but we have a GitHub repository of Python code that's doubled all of our data processing. So if you want to go use the same exact data processing that you saw today, but in Python code, you can do that. You can download that as a freely available open source library.
Great, thanks. And then there was a question, a quick how-to. How can you export the graphs?
Currently, we don't have that feature. That would be, yeah, you'd have to do a screenshot.
Okay, perfect. All right. We are getting a lot of questions in. Does Fathom have a dark mode setting?
Does not, but that's something we could consider.
Awesome. I love that you guys went to Mac. I'm a big Mac user, so we love that compatibility. Is there a way to add additional derived parameters when converting data? For example, if you want to have dissolved oxygen and oxygen saturation?
Currently, there is not. You can only select one of the different sort of conversions for each variable. But if that's something that you get a lot of value out of, then go ahead and let us know, because we're planning on a lot of our future updates are going to be coming for what you all want the most. So if that's something that you really want that is valuable to your workflow, let us know, and we can make something like that happen.
Perfect. And then has Seabird Scientific removed the pop-up windows that occur when processing data?
Yeah, that's kind of since the redesign of our full UI that feature's gone. Yeah.
Awesome. And then another question, will it be possible to process only downcast or upcast?
Yeah, good question. I think that's something that is, if it's not already built into Fathom, then it's definitely coming soon, is the ability to, when you load in your files, you can choose, the default is to include all of the data, but you can choose to process just the upcast or the downcast if that's something that you prefer, because we know that that's something that's important to a lot of users. Maybe they don't care so much about their upcast or they don't care so much about their downcast, so you can select just one or the other. So yeah, that's definitely something that we want to look for.
Awesome, thanks, Dane. And then when will the new software be available?
So it's
available
currently
now. So,
oh, sorry, go ahead.
Yeah, and you can get it through the Microsoft Store or the Apple Store. But you can also go to software.seabird.com, and that webpage will give you a whole bunch of links to the two stores too.
Awesome, thanks, Ryan. And then to follow up, when can we expect this to be released for other application 911 plus?
Yeah, so that's a great question. So like I said at the beginning, we're going to continue to be rolling additional instruments into the software in the coming months and years here. 911 Plus is absolutely on the list, but we don't have specific dates for each of those instruments to be included at this point. But if there are ones that you would like to see sooner rather than later, please definitely let us know, because your input, like we've said, definitely influences our development priorities. So if you want to see 911 Plus sooner, let us know, but that one is absolutely on the list.
Great, thanks. I know there was another question about loading and processing hex files from an SBE 911 Plus in Fathom, and it sounds like that's something you guys will release in the future.
Yes.
Yeah, that's right.
All right. Is it possible for the user to add their own sensors if the command set is known, or would we need to wait for that sensor to be added?
For data processing, so if this was for a sensor that's like outside of exponential equations that Dane was just talking about, then yeah, you'd have to wait. If you need a special equation to derive your parameter in data processing, you have to wait for the new feature to be added. Yeah.
Thank you. And then another question, do you know how the live data acquisition compares to that of CSAVE?
It's it's kind of working in a similar capacity. So it's basically the data is being saved to both the computer and the instrument, and then you can export it out. So yeah, it's similar in features.
Great, thanks. Will I need to return my instrument for a firmware update to utilize the new software?
Yes, I can take that one. So like I mentioned at the start, we focused on just the most recent firmware versions for the 37s, all versions, and the 19 plus V2. Those firmware versions have been stable for many, many years now, so they haven't changed for quite some time. But I know those instruments are quite robust and have a long lifetime, so there are many of you who have much older instruments. For the 37, some of the firmware versions are pretty tied to specific hardware iterations. So those are typically not able to be updated to newer firmware versions. If you have a 19 plus, so a V1, there has always been an upgrade available via service to upgrade your V1 to a V2, and that's via service with kind of all the standard pricing that's always been in place. But if you have a current firmware version on either the 37 or 19 plus V2, there's no firmware update needed, no need to send in your instrument. You're able to use Fathom today.
That's awesome. So everybody go download it. And it looks like Lindsay has shared the link, so definitely check it out. Another question that's come in, we previously could use a .psa files for each processing feature. Is there a way to save PSA configurations for different processing protocols?
Yeah, that's a great question. Not yet, but soon. The one thing that the software currently does do is that those settings that you select in your data processing, the next time you start up data processing, you're still going to have the exact same settings saved in there. So it remembers the state in between multiple processing iterations, but there's not currently a way to save out a PSA file or something similar to that. But the plan is to actually be able to have that and to have you be able to load those sorts of configurations or those workflows in, and then that'll help expedite your process, and you can have a number of different saved workflows. And that's particularly useful if you're bouncing between multiple different types of processing. Then that's something we want to definitely support.
Perfect, thank you. This is a follow-up to a question. You mentioned that Fathom can connect 2 CTTs at once. Does Seabird have a control box that can connect 2 CTTs at once?
I assume you mean like an actual like hardware interface kind of box. So no, there's not been any hardware work in tandem with Fathom to enable that type of functionality. So that's specific to Fathom. Like if you're working with multiple 37s, for example, on your bench and trying to get data off of them or set them up for deployment, you can have them all connected at the same time. So that was the focus for this.
Awesome, thanks Heather. And it seems like we're getting some questions on the tools, specifically the one that can read the battery life. So can you explain the endurance simulation? How do you get the values for the battery or memory endurance for a particular deployment?
Yeah, so that's a great question. So essentially, we have some battery endurance calculation formulas that live in the manuals for each one of the instruments. So we're just using the same formulas that are there. So it takes into account a number of different things. For a 37 SM, it's mostly just the sample rate because we know approximately how much power it takes over time, and the sample rate is how much time it's actually turned on. So you can use that to roughly calculate how long you expect new batteries to last. That's the one thing to keep in mind, is that the battery endurance calculations are always with the expectation that you're putting in new batteries before the deployment. The 19 plus V2 calculation gets a little bit more tricky, especially when you have some auxiliary sensors attached, or if you're in profile mode versus moored mode. But at the end of the day, we're still using the exact same calculations that are in those manuals. So if you're really curious about how those sorts of look, then you can find them there.
Awesome, thanks, Dane. Will bulk processing data be available in Fathom?
Yeah, so this is something that we sort of touched on earlier. I'm guessing you're meaning like processing multiple files at once. And that, yeah, the goal is definitely to get there. It's not there yet, but we want to be able to allow you to process multiple files at once to really expedite your workflow.
Perfect. And there's been some questions about the GitHub. Is that public?
Yeah, it's a public repository. You can also find that at the software.seabird.com address is a link down toward. Yeah.
Awesome.
The same that Lindsay just put in there. It's also in the chat.
Great. All right, I'm just filtering through all the questions. Are you planning on allowing for custom header fields like CSAVE currently has?
If you're referring to in your, for example, like your hex files or something like that, then yeah, that's something that's an option that you can generate during the data upload process. You can put in those custom information to identify your file. If you're referring to some specific custom header information during data processing itself as output into, for example, a CNV file, that's not something we have yet. But if that's something that you want, then it'd be helpful for you to let us know like how you'd want that, what you'd use it for, because that can help us design a feature around that.
Perfect. And Lindsay, I don't know if there's an email that you can drop in the chat where if folks have, or like a feedback mechanism, if folks have recommendations for improvement, we can get these recorded. And this is another question about CSAVE. Will the data acquired by CSAVE be able to be processed in Fathom?
That would be a file generated, so that would be a hex file. Yeah, that would be able to, I think we are be able to open that in the processing.
Perfect, thank you. Is there any functionality related to live streaming moored instrument data to a publicly accessible website or viewer?
No, this is considered to be just one instance running and not really run as a server.
Perfect. When can we expect, I think you guys already answered this question. When can we expect 911 plus Fathom and Python processing support?
Yeah, that's similar. So we don't have a specific timeline, but it sounds like 911 plus, at least from this group today, is of most interest. So it's definitely kind of bumping up the list a little bit there, but it's coming soon. And as soon as we can communicate an actual date for that release, we will.
And I've also seen 25 plus Suna and HydroCat EP. So I'll make sure you guys get all the questions so you have all that. And if you guys have recommendations, please type them in the chat and I'll make sure that they're shared with Dane, Heather, and Ryan.
Awesome, thank you. Yeah, I've been taking notes along the way as well. This is a really great questions and feedback, so thank you.
Awesome. Will there be functionality to mod the output of the sensors in the live view?
Can you clarify can you repeat that?
Will there be functionality to mod the output of the sensors in the live view? And Bobby, this is a question from you. If you want to add a little bit more to that.
Not really exactly sure what you're asking there, but you can, the auxiliary sensors in real time, you can collect data from them and then export them into the hex file.
Thank you. And Lindsay provided that email, so these questions can also be directly emailed to the team. All right, Bobby followed up. For example, add a transformation of the data in the live view chart.
I see. Yeah, if you wanted to like further transform your data or do some kind of equation like that. We currently don't have a plan to do that. But yeah, and all these new features and suggestions, please send them through the support link.
Perfect, thank you. And then we had another question come in about processing. Can you talk about batch processing? Is that an option or is that coming soon?
Yeah, that's something that's coming soon. And from the amount of you people asking for it, it sounds like that's something that's pretty hotly requested. So bumping up the priority chart for sure.
Awesome. And we also got another question, if it was compatible now for 19 plus with a FM module, which I think you guys are going to be working on in the future.
Yeah, that's coming in the future.
All right. Gosh, lots of questions still coming in. What is the transition process going to look like using different software for different sensors versus switching everything?
Yeah, so I can speak to that one a little bit. This was something we debated kind of internally quite a bit, honestly, because it would be definitely cleaner to have a software release that's a hard cutover. Every single instrument is now supported and in it, makes it a little bit more straightforward. But that is a pretty hefty amount of lift, and also there's a potential for us making some design decisions that all of you didn't necessarily want to see. So we wanted our software development process to be a bit more of a dialogue with our community and making sure that the changes that we're making are the things that you want to see. So we chose to focus on really building out the back end to be able to handle the complexity of our product portfolio, and then focus on 2 instruments to start. So the 37 and the 19 plus. So kind of similar in terms of they're both CTDs, but different in terms of application, auxiliary sensors, things like that. So got a fairly good breadth of complexity to start. So for now, all of our existing software, so CSoft, UCI, all of those will continue to be available. They are not actively being developed feature-wise, so we're not adding new interesting features to CSoft at this point, for example. But if there are critical bugs that impact deployments or data processing for people who are still using instruments that are supported by that software, we will absolutely work to address those. So there's no concern on your end there. But as we continue rolling instruments into Fathom, for example, once we get everything that's in CSoft into Fathom, no further development will happen on CSoft. So the software will continue to be available to you. So it's there, but we're not going to be making any improvements after that. So that's a little bit of time out. Obviously, we've got 911 to roll in, 39s, 25s, all sorts of instruments there. So it'll be a bit of time. But again, that will continue to be available to you.
Thanks, Heather. And I just want to say you guys are getting a lot of kudos for being open to feedback and considering community needs. People are really appreciative, and they're also really grateful that GitHub is free and available. So kudos to Seabird Scientific to listening to their users and making these changes. Another question that just came in, could I use the software from the command line?
Yeah, so that's essentially the terminal tab that I showed there just briefly. So if you know your commands and you just want to type them in right there, you can do that. And you'll see the live feedback from the instrument. So that's equivalent of CTerm.
Thanks, Ryan. Is the SBE 37 equivalent to HydroCats? So can we use Fathom with HCEPS? Lots of acronyms here.
We do have a lot of acronyms for sure. So yeah, currently 37 and the HydroCat and HydroCat EP are different. So currently HydroCat and HydroCat EP v2 are not supported in Fathom, but they will be. They are on the list.
Perfect. And so you guys talked about exporting files. Is there a way to import XML files that come from Seaboard?
That's a great question. So if you're referring to XML files like from, for example, a data upload or something, then currently no. That's something that is definitely on the priority list that we'll be working on pretty soon. If you're referring to loading in something like XML files, then those are what you can load into the data processing for actually, having the configuration of your instrument. One other aspect that we didn't get to is that if you need to update the calibration on your instrument based off of a .cal file, then that's also one of the tools that we have to allow you to make sure that the calibration coefficients on your instrument are up to date. So those are the main 3 ways that you'd be importing files throughout Fathom.
Awesome. Thanks, Dane. Seeing that we're 4 minutes till 3, I'm just going to ask 2 more questions and then we're going to probably close out. And again, if we didn't get to your questions, we're trying our best. Email techsupport@cbird.com and visit the cbird.com website that Lindsay provided. All right, so what auxiliary sensors are supported?
That's the 63, the 43, the EcoFL NTU, and the EcoFL currently.
And what does the update process look like for Fathom?
So the updates are going to run through the stores, and so you'll get once there's an update available, you'll get a notification, and then you can either select to update the application or not.
All right, and you're answering these fast, so how are time zones handled?
Yeah, so that's something that we have built into the app, is the ability to handle different time zones. I think by default it's set to UTC because that's the most likely to apply to everybody, of course. But if you want to use a different time zone, like you want to use your local time zone, or you're planning a cruise that's going to be in a different time zone, you can set the software to be set up for that time zone to make sure that that timing all syncs up properly. And when you're communicating with your instrument, we make sure that the instrument is synced with your computer's time. Or at the time zone attached, basically, to make sure that you're actually setting the correct times and you're not getting too confused along the way.
Perfect. And then we had one more question come in about data processing. Are the data processing libraries identical to the older Windows software, or are they rewritten and available as APIs?
Yeah, so that's they are rewritten, but they are functionally identical. You should be getting the same output from our new Fathom software as you would from running it in SB data processing. And those are similarly the same as the Python repository that we have been talking about that you can access via GitHub. That Python code also has those data processing libraries. And those, because they're open source, you can use them essentially as APIs for your own processing needs if you don't want to be running that within Fathom for whatever reason.
Great, thanks, Dane. So we're gonna close. I just want to thank you guys so much, Heather, Dane, and Ryan, for presenting on the MTS member webinar series. You are getting so many kudos, especially they're really excited about the real-time data display, the batch upload options, and I'm really excited to see all this feedback from today incorporated in future generations. So as Lindsay has mentioned in the chat, we have their email and the website. Please, guys, email them questions. We'll send them the chat list and follow up, and then I'll send the website again. And thank you, Heather, Dane, and Ryan. We really appreciate your time, and thank you for everyone else attending. All right.
So much for having us.
Of course. Thanks, guys. Have a good afternoon. Bye.
Bye.
Bye.